In our next unit, we're going to be looking at conic sections. As you can see in the illustration here, a conic section is basically taking a piece of a conic. You can see here that the conic is represented by the purple cones. It's basically two cones on top of each other, held together at the tip, at the very apex of the cone. It almost looks like an hourglass figure. And so a conic section is just taking a cross section of this conic, this cone, and you can see here that that slice, that plane, almost like that yellow slice that you see there, what it forms is, in red, you see that it forms a circle because you're kind of taking a cut perpendicular to that cone, and so you just form that top, which is the circle. Now, as that cross section moves, you'll notice that the shape of the conic section will also change. See right there, as we now take it at more of a slant, now we have more of an elongated circle, or you can describe that as another type of conic is called an ellipse. Okay, so we're going to be looking at ellipses as well. So our first conic section we're going to examine is the circle, but then as the conic section moves, you can see now we form an ellipse, and depending on what angle you take that conic section at, the ellipse may grow more elongated or more like a circle. Now you can see here that at the very end it starts to then get cut off, and then we no longer have a top of the ellipse, and then what ends up forming is this shape here. Hopefully you're able to identify that something that you've seen before is called a parabola. You've seen this as a parabola before. That parabola can change, of course, as the conic section also changes. Okay. And then as that yellow cross section starts to become perpendicular to your conic, you actually start forming, you can tell now, you're cutting through two cones, and so you're going to be forming this shape here, which we call a hyperbola. Hyperbola, okay? Not parabola, these are hyperbolas, okay? As we go through the units, we'll notice each conic will have its own kind of characteristics, but they're all kind of solved in the same way. So we'll examine those characteristics as well. Okay, so those are basically the different types of conic sections. Now let's take a look at our first conic section, the circle. In example 1, what we want to do is just rewrite the equation so it's in a more proper form. We're used to seeing circles in the center radius form. If you recall from a previous class, you will remember that the circle can be written in a form such as x squared plus y squared equals r squared. This tells us where the center is. In this case, we don't have any kind of transformations take place. And so in this case, we just have the parent function, which would have a center at 0, 0. And then we know that on the other side of this equation, we have the radius. So that's why it tells us the center radius. All right, so let's go ahead and complete the square here. We notice now that there's a lot of extra numbers associated with this equation, and so we will have a transformation for this particular circle. Okay, so to complete the square, what we want to do is pair up like terms. So we have x squared and 4x, and then we also have a y squared and 6y. And since those are our like terms that we want to combine together, I'm going to go ahead and move over on the other side our 4. So now that'll become negative 4. All right, so since we have like terms here, we notice that x squared and 4x, or rather negative 4x, don't really have much in common that we can really factor out other than the x. That won't really do anything for us. So what we want to do here is actually complete the square. So if you recall, in completing the square, we're going to have to take that negative 4x, take the negative 4, divide it by 2, and then square it and add it on. Remember, whatever you add on to one side, you also want to add on to the other side. So we're going to add negative 4 over 2 squared over here as well. And then for the y's, we're going to take our y squared plus 6y, complete the square. So we have y squared plus 6y, and we need to take the 6, divide it by 2, and square it. But remember, whatever we do to one side, we must also do to the other. So on the right side, I must also add a 6 over 2 squared. From here, we can simplify. Now, the whole purpose behind completing the square is understanding that the trinomial now becomes a perfect square. It's a perfect square trinomial, which can now turn into a binomial squared. That'll give us x minus 2 squared. And then for the y's, we will get y plus 3 squared. And on the other side, if we simplify all those values, we're going to get negative 4 plus a negative 4 over 2 is negative 2 squared. That'll give us 4. Oh, look, those will just cancel out with each other. And we'll also be left with 3 squared, which will be 9. So altogether on the right side, that'll just be 9. So there's our equation in center radius form. Okay, that is center radius form. And then our center is defined by how our x and y shifts. Keep in mind that because the numbers are contained within parentheses, that tells us that we are actually shifting to the right by 2. And again, because this 3 is contained within parentheses, we are shifting down by 3. Because the 9 is really made up of 3 squared, we know that the radius is a value of 3. So, kind of putting everything together then, our center is at, if we're shifting right 2 and down 3, our center will be at 2, negative 3. And our radius will be at 3, or our radius is a value of 3 rather. Okay, so there is our center and radius. And we can even go ahead and sketch that circle. When you draw your circle, we're going to label. We go to 2 and negative 3. And I'm just going to go a little bit further as well because I am accounting for my radius, in which I have to go up, down, left, and right from my center. I see that my center is at 2, negative 3, so I go over to 2, negative 3, I put a point. Since this is my center, from here, I should go 3 in all directions. I should go 3 to the right, 1, 2, 3. I should go 3 to the left, 1, 2, 3. I should go 3 up, 1, 2, 3. And I should go 3 down, 1, 2, 3. So these points kind of help me to visualize where my circle should be drawn. And of course, if I had done this more accurately, we would have a more of a perfect circle, but our circle would look something like that. Okay. In terms of the values, you can see here that one of the values is at 2, 0. Another one is at, 1, 2, 3, 4, 5, negative 3. We have another one at 0, negative 3. And we have another one at, at 2, negative 6. Like that. Okay. All right, so that'll do it for our first lesson on circles.